Bloc is a well-known and established library when it comes to state management in Flutter. It promotes good practices such as immutability, and it has one of the best ecosystems of supporting packages and documentation built around it. In spite of all these benefits, using the Bloc package is painful at times, and the cause is none other than boilerplate. The version 6.0.0 and upwards of the Bloc package comes to make this library palatable to the masses. It gives you the ability to use a lighter version of Bloc called Cubit, and it also removes a bunch of boilerplate. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. In this tutorial, we are going to build a rather simple app, and we are going to implement it both with Cubit, which we could call a lighter version of Bloc also, and then with Bloc, the core one itself. It's going to be a simple weather search app where you can enter a city name, or even some gibberish, but I'm going to again enter London just for the sake of an example, and it's going to give you a fake temperature in your particular city, or it can also show you an error message with a snack bar that we couldn't fetch weather. This is also just a randomly generated chance that it's going to show an error message instead of regular data. Also, this tutorial is suited for both beginners who would like to learn Cubit or Bloc from scratch, and also for developers who are already kind of experienced with Bloc, but they would just like to learn about Cubit more, or maybe even just some of the changes which came out with the version 6.0.0. Also, we do have a starter project prepared right here, which includes some of the boilerplate which every single Flutter app needs, for example, this main.dart, and we also have the UI already pre-built. The only thing which is not yet built is the Cubit or Bloc part of this app, so that means that the state management is not yet built. So if you would like to get this starter project to get going with this particular tutorial, be sure to check out the written tutorial from the link in the video description, where apart from this starter project, you can also find all of the code written in this video, links to the libraries, links to some resources, which I'm going to be mentioning in this video. And also you are going to be able to go through this tutorial at your own pace in its written form. So let's take a look at the already implemented classes. So here is the UI. We can show initial input, the loading indicator, which you could have seen here. This is the input. Loading indicator is displayed right here, and so on. And yeah, so here is the input. And that's about the UI. You don't really need to focus that much on it. We're going to come back here once we actually have the Cubit or Bloc implemented. But what's more important for us right now at the beginning of the tutorial is the weather model, which looks like this. It's a simple class. It has a city name string and temperature Celsius double field, and it also has overridden equality to make it value equality as opposed to the default Dart's referential equality. And then we also have a weather repository already implemented, which just simulates network requests. It has one method, fetch weather, which accepts a city name. And then what we do here is that we just delay the execution by 1 second. And then we simply generate a random temperature, as you can see right here. And we also have a chance, 50% that is, to instead throw a network exception, which is going to trigger that snack bar from the bottom, which will inform the user that there is no network. Before we jump into implementing the Cubit and Bloc for this particular weather app, let's talk about Cubit and other basically immutable state management solutions from a high-level perspective. Because although there is just way too many state management packages right now on the Flutter scene, it all comes down to the basic decision of having either mutable or immutable state. So we probably all get started mutating individual fields inside a state object of a stateful widget or inside a change notifier, right? So you can have something like this, my change notifier. This is, by the way, coming from the written tutorial, so definitely check it out if you want to copy this code yourself. And you have a change notifier with two fields, and whenever you change a state, you trigger some action, you just mutate that field in place to a new value, and then you notify listeners in the case of a change notifier. Or in the case of stateful widget, you would just call setState, but it's basically the same thing. You have a mutable field. And then we have an immutable equivalent of this simple change notifier, which we can build with Cubit. And it's going to do the same thing, but instead of overriding fields in place, it's going to basically generate a new copy of these two fields, which has a bunch of benefits. So if we go ahead into the pubspec.yaml file and we add Cubit as a dependency, or actually we are just going to add the block package and the Flutter Bloc package as dependencies because block is built on top of Cubit. That means that having block here also adds Cubit together with it. The same goes for Flutter Bloc. So once we save that, get all of the dependencies and come back to main.dart, how would we be able to build this sort of a simple functionality with Cubit? Well, instead of having the state, that means the fields, and the thing which controls the fields in just one class, we would have two classes. One would be for the fields, we call it state, and the other one would be the Cubit, which will change the state. So let's go ahead. I'm again just going to copy the code from the written tutorial because this is just a simple brief explanation. We're going to delete it in just a bit, but basically we have my state here. Just make sure to override equals and hash code when you're implementing this for real and not just for an example. And then we have my Cubit. We import Cubit over here. And as you can see, it looks suspiciously similar to the mutable change notifier. But what is quite different here is that the fields are inside a separate class from the Cubit. The Cubit holds only the change state method, which tells the Cubit to emit a new instance of my state, which has fields set to 0 and new value, whereas the initial state of the Cubit, which is passed into the superconstructor, has my state containing 0 and initial value. In both cases, the second field was changed to new value, right? Both here and in the change notifier, the same thing happened. We have updated the second field basically, but whereas in the change notifier, we have truly updated the second field in place, we have mutated it. In the case of Cubit or block also, what we are doing is that we are emitting the whole state, both of the fields at once. And this enables very simple way to track history of state changes, just like you have a history in your browser. You can have the same history of what kind of a state was there previously in your mobile app, and then you can just revert back to the previous state in history. That is very easy to do with immutable state. And also there are many more benefits, and you can learn about them more in depth from the tutorial from the card in the corner. Now just a brief side note for advanced users of the block package just trying to understand Cubit and how it works. So you can see that something is missing here compared to block, and those are events. Instead of having events, we have simple method called change state, which then updates the state, or should I say emits a new state. That's basically the only difference. As you can see right now on the screen, Cubit has functions, whereas Bloc has events. But this seemingly simple change has far-reaching impact. While it simplifies code quite a bit, you lose the ability to easily track incoming events. So if you would like to perform something called event sourcing, you should definitely choose Bloc over Cubit. And if you would like to learn more about event sourcing and all such things, there are links to everything in the written tutorial, so check it out from the link in the video description. If you're completely new to this package and to the block pattern itself, don't worry, because we're going to cover everything in this tutorial. This was really just a note to the more advanced users who may be looking for events, but they are just nowhere to be found in this simple example. Cool, so let's now delete these examples of change notifier and Cubit, and let's build this app for real. So while we have already added the block package to the pubspec YAML, which also adds Cubit, as I've already mentioned, the next step is to create the weather Cubit and weather state. Again, we want to have separate classes for state and for the Cubit, which emits new states. Now, we would be able to create these classes and files for them fully manually. That's completely possible. But there are also handy extensions for VS Code and IntelliJ. Again, links to them are in the written tutorial. So if we have a chance to use such extensions, we should definitely utilize it. So for VS Code at least, which I'm using right now, it's called Bloc. Just search for it in the extension tab, and here you go, Bloc from Felix Angelov. Just install it, and once you have it, you wanna right-click on the lib folder, and we're going to say Cubit, new Cubit. Let's give it a name, weather, just like that, and it has successfully generated weather Cubit, which is awesome. Now we can expand this thing, and you're going to be able to see that we have weather Cubit.dart and weather state.darts. As a rule of thumb, I always create the states first, because when you think about it, states are the reason why you want to create a Cubit in the first place, right? Because without a proper representation of the state of the Cubit, you just cannot possibly write the logic that will emit these new states. So what kind of a weather state do we want to have? Well, we are going to create weather states, multiple ones, for a asynchronously loaded resource, right? Because in the weather repository, we can see that when we fetch weather, it returns a future. And this means that in the UI, we need to represent the initial state, which is already created here by the extension, which will represent the state for when the user has not yet taken any action, aka we just want to show this initial search bar and nothing more, no temperature, no error messages, nothing, just this initial search bar. That's the initial state. And then we want to have a loading state, which is going to be emitted whenever we are waiting or awaiting for the future to complete. And then two next states, which are going to be present here, are the successful state, when weather was loaded successfully, and then an error state when we got a network exception instead. So this means we have 4 states that we want to represent in total. So let's do just that. Actually, we are going to add a constant constructor to this weather initial, just for the purposes of really just probably premature optimization, but hey, constant constructors are really cool. We also need to actually add it to weather state, to the superclass, like this. And also, if you'd like to learn more about constant constructors and constants in Dart, you can do so from the tutorial from the card in the corner. Now that we have that, the next state should be class weather loading, which extends again weather state. And again, it's going to have a constant weather loading. Actually, we can just copy this. The next state will be weather loaded. You can hit Control or Command D to select the next occurrence. So loaded, at least on VS Code, that's how it works. And this weather loaded will not be just an empty class, because we actually do want to hold some actual state field in this particular class. That is going to be a final weather, which is our weather model class. Let's call it weather, and let's add it to the constructor like that. And now we need to override the equality to be a value equality. This is going to add a bunch of boilerplate to the code, but we're going to live with it because we are just building a tutorial example app. However, if you are building a production app, you should probably not do what I'm just doing to generate equality like this. I am, by the way, using an extension for VS Code called Dart Data class right here from Bendix.ma. But you should probably not do what I just did and just create a bunch of boilerplate yourself right here. You should probably use something called Freest, which is an awesome package which has a support for unions, which are basically subclasses on steroids, we could say. And it also adds all the needed value equality for you automatically. It works by code generations. And again, link to it is in the written tutorial, to which you can get from the link in the video description if you have not yet heard about it. You actually absolutely need to override equality for your state classes, because otherwise block will not emit two states which are equal after one another. And if you leave in the referential equality instead of overriding it, you can sometimes arrive at the situation which will be acting weird, and you are not going to understand why a particular state was not emitted until you remember that, oh, I forgot to override equality, and you're just going to waste a bunch of time. So you should always override it to have a peace of mind. All right, the next state, the last one, is going to be weather error. So again, hit Control D, say weather error. And this one is also going to have a final string message signifying the error message. And let's again add final field formal parameters and generate equality using the extension. So this is what we have right here. 4 states: weather initial, weather loading, weather loaded, and weather error. Again, you can get all of this code from the link in the video description. So having done this, let's now implement the weather Cubit, which will perform logic of getting the weather from the repository and then also emitting these states which we have just built. This is the code already generated by the VS Code extension. It's basically a weather Cubit which extends Cubit of weather state, and then it passes weather initial to be inside the superconstructor, which makes it, how else, the initial state. Again, initial state will tell the UI that it should display only this search bar and nothing more. Now, as proper developers, we are going to sort of prepare for dependency injection by having a field, final weather repository, containing the weather repository, and we're going to sort of prepare for constructor-wise dependency injection. So basically we will need to pass a weather repository instance to the weather Cubit, and well, then we simply want to create a method called getWeather, but because we are going to be operating with the weather repository which returns a future, this must also return a future, but it will be a future of void, because we don't really want to return anything from here. We just want to make sure that this method for getting weather can be asynchronous. It's going to accept a string, city name, and again a sync here, just like that. And what do we want to do now? Well, at first we want to emit a state. So if this is the first time that getWeather is called, the state is weather initial, because it is set to be the initial state. But then we need to emit a new state immediately that this getWeather is called, to indicate that the UI should display a loading indicator. We can tell this to the UI by emitting the state called weather loading. So let's do just that. We're going to emit weather loading, and that's it. Actually, we could use the constant constructors here just for the performance benefits, but actually let's not confuse ourselves here. Probably I'm just going to use the new keyword like that. If you emit new, it's new by default. Then of course we want to fetch the weather from the repository, and we are going to put it inside of final weather. Let's make it equal to await, of course, weather repository fetch weather, and just pass in the city name, which was in turn passed into this getWeather method. So now that we have this weather, let's think about what we should do with it, right? Well, we should emit, again, weather loaded this time, which is the state which takes in a weather instance. But how are we going to handle the possible error? Well, we know that fetch weather can throw a network exception, so we need to account for that. Therefore, we are going to wrap this whole code block inside a try catch block. So let's move this code into try, and in the catch clause, we're just going to say on network exception. And in such case, we want to emit weather error. And now we're just going to hard code an error message in here. I'm going to leave it up to you how you do it in your production apps. You should probably think about just passing around some codes, some error codes, probably some integers or some constant strings, which you are then going to translate in your presentation layer in your UI using your favorite localization library into some actual user-readable messages. But for now, we're just going to hard code everything right in here. And well, that's really it for the getWeather method and for the whole Cubit as it is, right? So let's now move on to the user interface. First up, we need to make sure that this Cubit is available throughout our whole UI. We want to provide just one Cubit instance, and for that purpose, we can use a block provider. You are probably familiar with the provider package, and block provider is built on top of that package, built specifically to work with block in a completely seamless way. So let's move on to the main.dart file, and since we have just one weather search page, we can just wrap this with a widget called block provider. Let's import it from Flutter Bloc.dart. And over here, we're going to say create, which is going to instantiate a block, or actually the weather Cubit for now, because as you can see, we are using a block provider for a weather Cubit, not weather block. But we can completely do that because block is built on top of Cubit. Block, in other words, extends Cubit. So that means they are fully compatible, and you can use both Cubit and block with the widgets which the Flutter Bloc library provides. So let's just instantiate Flutter Cubit, but we mustn't forget that this takes in an instance of a weather repository, which in our case will be the fake weather repository. Okay, with this done, we can now access the weather Cubit throughout our whole weather search page. So let's go over there to weather search page and let's do something about it, right? The startup project, which you could have gotten from the written tutorial, already contains pre-built methods returning widgets. So we have build initial input, build loading, build column with data, which looks something like this. This is the column with data. And then we also have a city input field, which is a widget in itself, where we need to implement the functionality of actually calling the get weather method on the Cubit to start fetching the weather. Because all of the widgets or the methods right here are already prepared, all we need to do is to just swap this hard-coded build initial input, which is currently always displayed in the app, for a dynamically loaded UI based on the state which has been emitted from the Cubit. Actually, let me just run this app in the emulator, because currently we are just running the already prepared app for when I was preparing for the recording here. Here we go, and as you can see, we can enter a city here, but it's not going to do anything because all we are doing is just building initial input and we are not even calling any method on the Cubit, so that's not cool. Let's change that. We want to implement this with Cubit, so the way we do that is by providing a block builder right here. Then we need to specify as a type parameter, first will be the Cubit class and then the state class with which we want to operate. So weather Cubit is the name of the Cubit, and then weather state. This will automatically get the Cubit using the provider which we have added in main.dart. You can also obtain the Cubit manually if you really want to and provide it as a Cubit here. So just say block provider dot off context and provide weather Cubit, right? This is the standard provider or inherited widget syntax, but you do not need to do it because, as I said, block builder will perform this fetch automatically. What we do need to specify here, though, is the builder method, which provides us a context and a state which has just been emitted from the block, or in this case, from the Cubit. And what do we want to do here? Well, since we have just basic subclasses in here, because we are not using freezed, for example, which has the support of nice unions, we need to just check through all of the instances of the subclasses, because the state is of type weather state, which is the subclass of every single state class we have built, right? So we're going to check if state is weather initial. In that case, we want to return build initial input. In case that, else if state is weather loading, loading, we want to return build loading. Again, else if state is weather loaded, we want to build, return build column with data and pass in state dot weather. And lastly, else, which in this case, this means that state is weather error. Right, let's put this into parentheses. Then we want to return again build initial input, because in the case of an error, we're just going to show a snack bar, which we are not yet showing, but the UI will basically look the same as if it was an initial state that was emitted. But again, we want to show a snack bar. So how can we do that in reaction to a state change coming from the qubit? Well, the code to showing a snack bar is very easy to write, but we cannot really put it inside the block builder, because then we are going to get an error message saying that set state or mark needs rebuild was called during build. Basically, when you are building the UI, you should really only build the UI, return some widgets, and not do anything else. For example, you just cannot navigate to a new page during a build. And the same thing applies to snack bars, which are basically also just navigating to a snack bar. You can pop it. It's really a route on top of your current route. You just cannot show a snack bar during a build. Also, Flutter can decide to run the build method whenever it likes, basically. And the same goes for block builder. And we definitely do not want to arrive at a situation where we show multiple snack bars because the current state of the qubit is the error state, but we just show it multiple times because Flutter decided to rebuild the UI for some reason of calling set state somewhere deep in the widget tree or something like that. So we need to have a way to perform showing the snack bar only once per state change, and also to show it in a way which is not going to cause any errors and red screen of death. That's exactly why there is a block listener. Block listener is a simple widget looking very similar to block builder, but instead of a builder, it has a listener method, and that's basically the only difference there. And you do not return widgets from that listener method, but you just perform some actions, some side effects. Now, we are not going to use a block listener here, but you definitely could block listener and basically just wrap block builder with that widget and then implement the listener method, right? All such things, and it would be completely cool. But as you can see, this creates nesting, and whenever you can avoid nesting, you should definitely avoid it as much as you can. And that's also why, instead of using block listener, we can merge block listener and block builder together with a block consumer, which is a class which very nicely provides us the option to build and also listen to the block at the same time. So let's do just that. And basically here we just want to check if state is whether error. In such case, we want to call scaffold of context, and then we just want to show a snack bar. Whoops. And the snack bar will be very simple, nothing too fancy, just a snack bar, and its content will be a text. And now we want to provide an error message to the user, so we are going to say state, which is coming from the qubit, dot message, like this. And now lastly, after we have built all this, which is basically showing different widgets or a snack bar in reaction to the states coming out of qubit, what we now need to do is to add the ability to trigger a state change from qubit. How can we do that? Well, we want to handle the case whenever the search button is pressed on the keyboard. And then we want to call the getWeather method on the qubit, which is going to trigger all of the state changes and all such things. So we want to add the call to getWeather on the weather qubit. All the way down in the weather search page.dart file, I have prepared a submit city name method, and all we need to do here is to basically get hold of the qubit. Again, we can do so using a block provider .off and do it the old-fashioned way, but we can also just do it in a more new way using extensions by calling context, block, and over here we want to provide weather Cubit. Again, we are calling block, but it is interoperable with Cubit, so that's completely fine. We're going to put this inside final weather Cubit. Cool. And now we just want to call weather Cubit dot get weather and pass in the city name, which was passed in turn into this method in the UI. Awesome. So now with all of these changes, we can now search for a city here. So I just put hello here, search for it, and we get an error, which is nice to see actually. And then some other city, hopefully we are going to get successful data, and we do. And you can see that everything has worked successfully. So this is it for the Cubit part. And now we are going to switch everything to block. It's going to be very simple and very quick because basically most of the things which we have built can stay in here. Definitely the checking through states can stay in here. The block listener can also stay in here. And also weather state can remain completely unchanged. And most of the things which are built inside Cubit can remain unchanged. There are going to be some really minor changes because basically the only thing which block adds on top of Cubit are the events. So there are not going to be a lot of changes to take care of. Also, I'm now going to commit this to say finish project Cubit, right? Commit this, and you can get this Cubit finished project and then also later on the block finished project from the written tutorial from the link in the video description, so definitely check it out. So the first thing we want to do when we are switching to block is to create a block, new block. Again, so just right click on the lib folder, block, new block. It's again coming out from the VS Code extension. Same thing should be available on IntelliJ or Android Studio. And you want to call it again weather. So now what's going to happen is that we're going to have this block folder, and it looks very similar to the Cubit folder, but we have one more file, which is for the weather events, like this. Let me actually close all of the files. And let's again begin with weather state. We're actually not going to do anything new here. We just want to go to weather state from the Cubit folder, copy all of the states, Control C, and go to weather state, Control V, or Command V on Mac, of course. And yeah, so that's basically it. We have just copied all of the states to the weather state.dart file present in the block folder. Now we just need to import weather here, like that, and we are good to go. Now that we have states, we should move over to events. And we basically know what kind of an event we should have here, because again, events are just a more boilerplatey, but for a good reason. Boilerplatey, as I've said, you can perform event sourcing. So if you want such things, you should definitely use a block. But anyway, we know what kind of an event we want. We want the get weather event, which in the case of a Cubit, it was just a simple method. So we're going to have class get weather, and it will extend weather event. And we're just going to have a final string city name here. And let's create a constructor for it. And that's it. You don't actually need to override the referential equality to be a value equality in the case of events. However, in the case of states, this is really what you need to do. So that's awesome. It didn't even take much time, but we have already implemented the state and event files. So now we're just going to move over to weather block and implement that. Again, it looks very, very similar to Cubit. We again want to have weather initial to be the initial state of the block. Again, we can actually come over to Cubit and copy the weather repository dependency field and paste it into weather block. Because again, we are going to need to have a weather repository. Let's import the weather repository class. Let's add it to the constructor. And now we need to implement the map event to state method. Events come into the block and states come out of it. In the case of Cubit, there are no events, but only methods, but still states come out of Cubit as well. It's just that Cubit really hides the stream, which is being used behind the scenes. And instead of using the regular Dart keywords for yielding new states from an asynchronous generator, as we are gonna do in just a bit in the block, you just call emit. And if we take a look at it, it really just uses a stream controller and adds a state to it. So still there are streams being used, but they are just really nicely hidden in behind the interface, right? Behind the emit method. In the case of block, we don't have such emit method, but instead we use an asynchronous generator, and instead of calling emit, we're going to call yield. Yield like that, and yield, for example, weather loading. Okay. However, we cannot just do it like this, because we first need to check if the event which is incoming into this method is actually the event which we expect. In our case, it's always going to be just the get weather event, because after all, this is the only event which we have. But in the case that you have multiple events, you definitely want to check for their type. So we're just going to say if event is get weather. And now we can basically do the same thing which we have done in weather Cubit. So let me just copy the try catch block from the get weather method, paste it over here, and just let's select all of the emit occurrences. So again, Control D or Command D, change it to yield, delete the first parenthesis or parenthesis. I'm not sure if it's possible to be in singular, but anyway, once we delete all of the parentheses here and change emit to yield, and then also we need to pass in the city name to the fetch weather method on the repository. But now we cannot just pass in the city name because we are not inside a method as here in the Cubit. We just got city name right out of the bat. But in the case of a block, we need to retrieve the city name from the event as a field, like that. So we say fetch weather event.cityname. And with these minor changes, we have just successfully implemented the weather block. So let's now go over to the UI and make it work with the weather block. Again, the changes are going to be absolutely minimal. The first change which we obviously need to do is to provide the weather block instead of weather Cubit. So let's just change the weather block, import it automatically, and here we go. We are now providing a weather block instead of weather Cubit. And then the only changes which we are going to need to do here in the weather search page is to change the block consumer to work with weather block instead of weather Cubit, and also delete the import to weather Cubit right here. So let's delete that. And now we're going to get a bunch of errors here, but let's import weather block this time, like this. And with weather block imported and this block consumer changed to work with weather block, let's just scroll down And let's also make sure that this submit city name will work with weather block. Oops, weather block. And again, because it's a block, we cannot just call get weather on it, but instead we need to add an event to it, which is going to be the get weather event. And we need to pass in the city name, just like that. Let's just quickly try if it works. So I'm going to hot restart the app just to be safe. And let's say New York. Search for it. And here we go. We can see that it works, which is good to see. So you have just successfully implemented the same app for the second time, now with a block instead of Cubit, and it didn't even hurt. So really, you can just always start out with Cubit, and once you find out that, oh, I'm probably going to need to do some more advanced operations, which only the block can do, like for example, tracking the events which are incoming into the block, you can just switch it just like that, no problem, switch from Cubit to block in really a matter of minutes, and you're gonna be good to go. To go through this tutorial again at your own pace and to get all of the code, check out the written tutorial available from the link in the video description. And if you are serious about becoming a great Flutter developer who can build real apps for clients or at a job, go to flutter.education. Link is also in the video description, by the way, to get the top curated Flutter news and resources aimed at improving your app development career. Over there, you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox. And if you don't want to miss more tutorials like this regarding Flutter packages, state management, and all such things about Flutter, be sure to subscribe to this channel and also join Notification Squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you with understanding the Cubit and block from the block package, give it a like and also share it with other developers who are surely going to find it beneficial too. Leave a comment if you have anything to say, and see you in the next video.